All right, the metric system. Where does it come from? Okay, and why do we do it? Well, metric comes from the Greek word meter, which means to measure. So the Greek word meter means to measure. So if you see geometry, geo means land, metry means measure, because geometry was originally meant to measure the land, that they were using those angles to measure the land, especially after the Nile flooded. Every spring they had to redraw their property boundaries after the flood. So they needed some way to measure their land. So geometry, land, measure, metry means to measure. So measuring. So measuring means you get numbers. And we like numbers on things. But numbers aren't enough. Okay? So I tell you it's 10 long. What does that tell you about it? Nothing. Right? It says nothing if you say 10 long. Okay? Put your hands that far apart. Is anybody going to put their hands the same distance apart? No, because we have no frame of reference. 10 what? 10 inches? 10 miles? 10 micrometers? Okay. So the point I'm trying to make right here is that numbers without units are meaningless. Meaningless. What does meaningless mean? Meaningless means it has no meaning. And how do teachers treat numbers that have no meaning? Write an answer that has no meaning? It's going to be marked wrong. They don't do it. To say something is 10 long, it tells me nothing about it. All I know is it's bigger than 9, but I don't know how big 9 is either. Okay. So I need a unit. So why don't we just use the English units that we use all the time? And I'll show you some flaws there. So the first question, how many feet in a yard? I know it's a trick question. Depends on how many people are standing in it. The more people standing, the more feet. No, but everybody knows that the feet in a yard is 3. Okay, so there are 3 feet in a yard. How many feet in a mile? The people who tend to know this are usually track athletes who have to run it. Because if I had to run it, I would want to know how many feet I was going. So, of course, logically, it's 5,280 feet. Okay. So those are the ones we use all the time. Not everybody knows mile. How about some more obscure units that we don't use very often in the English system? One of the units in the English system is the rod. Anybody know how long a rod is? Okay. A rod I've only seen it used one place. Okay? And it's a strange place. Okay? I grew up in northern Michigan. And for entertainment, I'd go canoeing. Now, when you canoe in a national park, because there's a big national park in northern Minnesota called Boundary Waters, and what it is bunches of little tiny lakes. So you canoe across a lake, and then you want to go to the other lake, you have to carry your canoe. That's called a portage. And you got to carry your canoe across the land to get from one lake to the other. Well, in the national park, portages are measured in rods. It's the only place I've seen it used. I don't know why they picked rods, but they picked rods. And a rod is 16 and a half feet. So, think about this kind of questions. How many rods in a mile? Could you do that math in your head? I know I can't. Okay. Is there any pattern to the number 3, 5,280, and 16.5? Do you see any pattern there? No, they're just random numbers you have to memorize. And that shows up all over the place in the English system. For some reasons, there's 12 inches in a foot, but there's 16 ounces in a quart. Actually, it's not some reason. The reason why they picked 12 for inches is because it's easy to divide in half, it's easy to divide in thirds, and it's easy to divide in quarters. That's why they picked 12. You get cut in half, thirds, or quarters really easily. For 16 ounces in a cup, or 16 ounces is the ounces. The reason why I picked 16 is because 16 is easy to cut in half over and over again. So you can find half of it, a quarter of it. Okay? That's why they picked 16, is because the math is easy by twos. Okay? But when I'm talking about length, I've got to work with 12s. When I'm talking about volume, I got to work with 16s. Are you good with math with 12s and 16s in your head? I know I'm not. So, we get to the metric system. Okay? And the metric system is easier to use because it's a decimal system. A decimal system means that every conversion from one unit to another is some power of 10. You're either going to multiply it by 10, or multiply it by 10 squared, or multiply it by 10 cubed, or divide it by 10, or divide it by 10 squared, or divide it by 10 cubed, or divide it by 10 to the fourth, which means divide by 10, 100, 1,000. Anybody see the benefit to that? Or does everybody see the benefit to that? Well, the benefit is that we can do that math in our head. So I want to give you a little history lesson where this metric system came from. Okay? It came from the French Revolution. Okay? Came out of the French Revolution. So the French helped us when we broke away from England, and then we helped the French when they fought against their king. Okay? And when the French revolted, they wanted nothing to do with monarchy. They didn't want anything to do with monarchy at all. They wanted everything based on nature. So they said, I want a system of measurements based on nature. I want to remove everything associated with the monarchy. You say, well, what's that got to do? Well, if you had a foot, what was the foot? Well, a lot of times it was the length of the king's foot. That's how long your foot was. However long your king's foot was, that's how long a foot was, which caused some problems. Things like when you got a new king, you got a new foot. And when you went from one country to the other, the foot changed size. See how that's going to make trade real hard to do? Okay? So they didn't want anything associated with the monarchy, so they wanted to get rid of the foot. And the fact that the foot changed from place to place, that's not based on nature. Okay? So they said, we're going to base all of our measurements on things on nature. So they came up with a whole system that the world eventually adopted in the 1870s. It took them 100 years for the rest of the world to adopt it. But they came up with it in the late 1700s. And they came up with this completely new system. They started using it. So obviously, France was the first country to go completely metric. Now, the second country to agree to go metric, you're never going to guess who it is. Oh, probably are, because I'm being silly about it. It was the United States. When Thomas Jefferson was Secretary of State for George Washington, he signed a treaty with France saying the U.S. would go metric. And the U.S. got on the line of going metric, and here's evidence that the U.S. really wanted to go metric. The United States, when it formed, had to make its own money. And it made the first money in the world that had a decimal point in it. It had the first decimal money. So up to that point, you would have like 20 shillings to a pound. You have to do math with 20s. Okay, those types of things. You traded coins, but the U.S. said, no, we just want a decimal point in our money. So the fact that we have a decimal point in our money is that part of that idea of the metric system. It makes the math easier. You don't have to deal with fractions. Okay? So the U.S. agreed to do it. And we actually were on our way to do it, but we needed to know how big their meter was, how heavy their kilogram was. So France made a kilogram and sent it to America. And on its way to America, it got blown off course by a hurricane, stranded on an island for a couple of years because their ship was wrecked. Eventually they got rescued, and 4 or 5 years later, the kilogram finally made it to America, but America couldn't wait for it. So America stuck with the British systems of measurement, the English systems, and we didn't immediately jump on the metric system like we said we would. Okay. So now, a few other countries have picked it up. Well, actually, most of the countries. Let me give you a list of the countries that have not gone fully metric. The list is the United States, Liberia, which was formed by former slaves from the United States, so they brought our system with them, and Myanmar, which used to be named Burma. I have no idea why Myanmar didn't change. But those are the 3 countries in the world that have not gone metric. And it causes us a whole bunch of grief. A mechanic in America has to buy 2 sets of tools because he's got the English sizes, 1/2 inch, 3/4, 7/8, and he's got to get the metric, 9 millimeter, 8 millimeter, 7 millimeter. He's got to get 2 sets of wrenches because we have 2 different systems that are used. Okay, so the metric system, where it came from. Okay, why did everybody want to adopt it? Well, they wanted to adopt it because of that decimal system. It makes it easier. Okay, because the metric system is repetitive. You don't have to learn different things for volume and length and height. Okay? So a metric system, I said it has 2 parts. It has up to 2 parts. You can have just 1 part. Okay, it has to have a base unit, and usually it has a prefix. So they got some base unit. This is our unit. And they have a prefix that they put in front of it. And what that prefix does, it tells you how many times to multiply that by 10 or how many times divide that base unit by 10, which you can do in your head because multiplying divided by 10 is just moving a decimal point. And the beauty of the metric system is they use the same prefixes for everything, and they always mean the same thing. So that we don't have to worry about length in numbers like 12 and 3 and volume in numbers like 16, 32, and 64 ounces. Okay? So all the systems use the same all the different base units use the same prefixes, which means the same conversions. So first, I want to give you the base unit, and what I need you to get is to know the name, its symbol, and get a picture of how big it is in your head. Does that make sense? Because you're going to have to picture how big this is, because I'm going to ask you what would be the appropriate tool to measure. Okay? So the base units, the things that we have base, the base unit is length. The base unit of length is the meter. They picked the word that meant to measure in Greek as the name of their unit for measuring, the meter. And the meter is a little bit more than a yard. About this far. Well, it's hard to tell on screen, but not that far. Okay? A little more than a yard. Still 39.1 inches, I think, off the top of my head. And its abbreviation is lowercase m. Lowercase m. That's its abbreviation. Yeah, see, we got to use the same abbreviations worldwide so we know what we're talking about. Because now when I use I can't use m for mile because m means meter. Actually, and the original definition of the meter was 1/10,000,000th the distance between the North Pole and the equator through Paris, France. That was the original definition. Okay. Now, the current definition is how far light will travel in some tiny fraction of a second. 1/300 billionth of a second. That's actually its definition. Now, the unit of mass, and mass we think of as weight. Technically, it's not the same thing, but mass is weight. So where we would use pounds and ounces, they use grams. Okay? And the gram is the weight of about a raisin. So it's a tiny mass. Okay? And its symbol is lowercase g. Okay? The base unit of time is the second. And time is the one place where we haven't gone metric completely. So when the French said, okay, we want to make a metric clock. So we're going to take a clock and divide the day into 10 even pieces. And divide each one of those into 10 pieces. And then divide each one of those into 10 pieces. They wanted to make a decimal day. And they actually built clocks that looked like that and put them up in towns. The problem was, in that town where they put up that clock, there was also a clock on the church spire that everybody would look at. And nobody ever looked at the official clock. They all looked at the one on the church because that was the one they were comfortable with. So as long as that second one was up there, as long as the original one was up there, nobody looked at the new one, and the new one went away. And that's why we have numbers like 60 seconds is a minute, and 60 minutes is an hour. The reason why we have those numbers is because the people who divided the day originally were ancient Babylonians. And instead of doing base 10 math like we do, they did base 60 math. So they divided everything into 60ths. I know I don't want to do 60 in my head. But 60, why 60? 60 you can divide into a half, a quarter, a third, a fifth, and a sixth. That's why they picked 60. Because it was easy to cut into small pieces. Because it's evenly divisible. Okay. Temperature. The official one is Kelvin, but they commonly use degrees Celsius. The symbol for Kelvin is a capital K. The symbol for degrees Celsius is a degree sign with a capital C. So Kelvin doesn't get a degree sign. We'll talk later about why that is. Okay? And you'll notice that these are capitalized. They're capitalized if they're named after people. There was a man whose title was Lord Kelvin. That's why it's named after him. There's a man who built thermometers whose last name was Celsius. Okay? So, the energy, the official one is the joule. And you see this is a capital J, again, named after somebody. But oftentimes, we will use the calorie. Hey, you've heard of calories before. The official abbreviation for calorie is CAL. Cal. Okay. So the official one is joules, but chemists like calories. Okay. Volume. How much space something takes up. It's the one place the U.S. went metric. The volume is, actually, they went metric for their sodas, but they didn't go metric for their gas. Well, actually, when I was in high school, we bought gas by the liter. And nobody liked it, so they went back to the gallon. Okay. So a liter is about half the size of a 2-liter bottle. Well, duh. Okay. And you'll notice that the liter is capitalized. And it's the only one where it's not because it's named after somebody. There was nobody named liter. Okay. What happened is it's about typewriters. Because on a typewriter, this is a 1 and that is a lowercase l. So if somebody wrote something like this, it was tough to tell if they were saying 21 liters or 211 when they typed it. It was about typewriters. So to get rid of this confusion about this last one, they said, we won't make that mistake if it's a capital L. So it's the one that's not named after somebody, but the reason why they made it capital is so that we could type it. Because we've all run into, imagine typing in an Arial font on your computer where it doesn't have any of those things. A lowercase l and a 1 look identical in Arial. Okay. Here's one you may not have heard of before. And it's the one chemists use most often. That's the amount of stuff you have. And the amount of stuff you had is called a mole. And it's the shortest name for a unit with the longest abbreviation. The official abbreviation is to write out mole and drop off the E. There are some other units that are using the metric system. These are the ones we're going to run into this year. We're going to use all of these this year. So that's the list I picked. So those are the base units. So now I want to talk about how many of those base units I have. Do I have 10 of them or 100 of them, or do I have 1/10 of it? And for that, I need the prefixes. And there are lots of prefixes. There's a big list in your book. The ones we are going to use this year most often, so that you need to have at the tip of your tongue. The first one is kilo. Kilo. Its abbreviation is little k. And it means 1,000 times bigger. It's 1,000 of those base units. So if I write km, kilometer, that means 1,000 meters. Right in the middle of writing, you're going to stop working? All right. 1,000 meters. So is that going to be a big different distance or a small distance? Well, that's take a meter and lay 1,000 of them end to end. It's going to be a big distance. And kilo, you see it on kilometer. Oftentimes we go kilometer on that. Or you see it next to grams, kilogram. But it actually can be put on anything. You can have kilokelvin. That's what you'd measure the temperature of the sun in. How many thousands of Kelvin is it? Now, there's a couple in between, hecta and deca. We're not going to use those this year. But we can't. But I don't want you to think I didn't know they were there. Okay, deci. Deci means 1/10. From decimal. When you move the decimal point, you've moved it by 1/10. Centi. Here we're back to money. Okay? Here we're back to money. You say, what do you mean we're back to money, Mr. Green? Well, I said the U.S. was the first to have decimal money. And what would we call 1/100th of a dollar? Well, we'd call that 1 cent. That's why it's called a cent. Centi. Another way to remember it, to remember that the number is 100, is century. A century is 100 years. So that, okay. Next one we use is milli. And its symbol is a lowercase m. Oh, we already used that for meter. So how do I know if I just write a lowercase m, do I mean milli or do I mean meter? Well, the answer is, if it's by itself, it can't be a prefix. So it's got to be meter. If it's going to be a prefix, there would have to be two of them. And that would be millimeter. And how do you remember that milli means 1,000? Well, if you're taking either French or Spanish, doesn't matter which one, how do you say 1,000? Well, the answer is mille. Okay? So that's a clue from your foreign languages. So millimeter would be 1/1000th of a meter. Give me a second here. Get my meter stick. Okay. Okay, so see if you see, there's my meter stick. Okay. And the numbered lines, ones with numbers, the distance between those is a centimeter, and the little tiny lines on the meter stick. I mean, look at the whole meter stick. Think about how many lines there would be if they were that close together. There'd be a lot of them, right? There'd be 1,000 lines. So, a millimeter is a tiny distance. Okay. So now we come into even smaller, micro. Now micro, well, think about where you've seen the word micro attached before. Microscope. Micro means tiny. Micro means 1/1,000,000th. Oh, got the wrong share on. Thank you. Oh, and you're gonna want to see this because it's a bizarre character. Come on, it's supposed to be here. Where? Yeah. So micro. Micro is tiny. Okay, 1/1,000,000th. So a micrometer is 1/1,000,000th of a meter. Now this right here, what the heck is that? Well, they ran out of M's. Okay, M is such a popular letter with all our units, we run out. So they wanted to have micro, and they wanted it to be an M, but we didn't have any M's left. They used capital M for something. So they went to the Greek alphabet, and they picked this letter. And that letter is mu. Mu. That's its name. Every letter has a name. Okay, so mu, it looks like a backwards Y or a U with a tail in the front of it. Okay, it comes out of the Greek alphabet, and the Greek alphabet over time changed. As we went from tools, they would write this, and then they let that back one come in a little bit more, and eventually they just made two hills, and then we had an M. that our M evolved out of that mu. That's where our letter came from. So mu is the symbol for micro. And it means tiny. Another way of writing 1/1,000,000th is 10 to the minus 6th power. Because I don't want to write 6 zeros. Okay? Even smaller, nano. Okay, nano, its symbol is a lowercase n, and it means 1/10000000th, 10 to the minus 9th. It's tiny. So when you hear the phrase nanotechnology, what they're talking about is making things that are 10 to the negative 9th meters in size. They're building equipment. They have built nanometer-sized electric motors that you put electricity in, they spin. Okay? And nanometer size is the N in N95 masks. What N95 means is that it stops 95% of the nanometer-sized particles, which is the size of viruses. So that's why they want to wear an N95 mask, is because you don't want to have to breathe viruses. We want something that will catch those viruses. Not perfect. You can actually buy N99 masks. Okay. So I put these in descending order. And the only one that's bigger than the base unit that we're going to use is kilo. Kilo's the only one bigger than the base unit. Everything else is smaller. So when I say kilometer, that means 1,000 meters. That's going to be a big distance. It's going to be about 6/10 of a mile. If you laid 1,000 meter sticks end to end, it'd go a long ways. Okay? Now, I don't want you to think that this is all the prefixes. Okay? They get bigger. The bigger ones are things like 1,000,000 is mega. 1,000,000,000 is giga. 1,000,000,000,000 is tera. 10 to the 15th is peta. You don't need to know those, but they do keep going up. You know who uses all of these? Well, computer industry uses all these. When I got my first computer, it had 16 kilobytes of RAM. 16,000 bytes. When I first came to Altaloma High School, they had the first megabyte hard drive. We were early adopters. Now, you buy flash drives that are gigabytes, hard drives that are terabytes, and they measure how fast computers do calculations now in petaflops, 10 to the 15 calculations per second. So the computer industry has picked up those bigger prefixes. They also go smaller. We said that this was 10 to the minus 9th. Pico is 10 to the minus 15th. Or sorry, 10 to the minus 12th. Atto, 10 to the minus 15th. And they just keep getting smaller and smaller. We will talk about things that are picometers in size this year. But we don't need you to know that prefix. So the prefixes I need you to know are those 6. Okay? So if I say centimeter, that means take a meter stick and cut it into 100 pieces. How long would each one of those pieces be? Why, each of those pieces would be less than half an inch. And the rest of the world uses centimeters the way we use inches. You don't use centimeters to measure how far it is across town. That you use kilometers for. They use centimeters. You can talk about it in terms of height. How many centimeters tall you are. And how many inches shoe sizes would be in centimeters. And a millimeter was where those lines were on the meter stick. So it's going to be about the width of the wire on a paperclip. Not the whole paperclip, just the wire. How wide is that wire? So a millimeter is a tiny one. So that means micrometer is so small you can only see it with a microscope. And nanometer is so small a microscope won't see it. So, just to make sure we're all on the same page, go ahead and put those in increasing size from smallest to largest. Increasing size always means from smallest to largest. Okay, when I'm given a problem like this, I always put down the base unit first. Even if it's not on the list, I put it down there. It happens to be on the list this time, but I always put the base unit there because I know everything in reference to the base unit. So I want something smaller than the base unit before on the list and bigger than the base unit afterwards on the list. So there's only one of these that's bigger than the base unit. One that's 1,000 times bigger. Kilometer. All the other ones are smaller. So then I just go through my head in size order and see which ones I run into or think about how big they are. Okay, smaller than meter is decimeter, but they don't have decimeter on here. That's tenth. Then I got a hundredth. Hundredth. I know a hundredth would be a cent, so that would be a centimeter. So the next one I run into in the smaller size is centimeter. That was a hundredth. Smaller than that, a thousandth would be, well, we have a prefix that means thousandth, and that was millimeter, and it's on my list. And smaller than millimeter is micrometer. So the list in order from smallest, micrometer, to largest, kilometer. So anytime somebody says increasing size, put the biggest one last. Okay. A liter is about a little bit bigger than a quart. And a quart, I was way old. I was in my 20s before I realized that they called it a quart because it's a quarter of a gallon. That's where they got the name quart for it. Now, we don't use volume measurements bigger than a liter in chemistry class. We're not mixing that many chemicals that often. But we will use less than a liter. But when we measure less than a liter, the only one we use regularly, so that you have to have a picture in your head, would be milliliters. Okay? If you pick up your soda can, it will tell you it's 16 ounces at 253 milliliters. I think that's what it is. Oh, no, it's 235. 235. Okay? So a milliliter is about 20 drops of water, or it's about a sugar cube, the size of a sugar cube. A little smaller than a sugar cube. Okay, but volume is strange because we can measure volume two different ways. If I want to measure volume in my kitchen, I grab a measuring cup and pour stuff in. But when I want to measure the volume of a box, I can calculate it by doing length times width times height. Right? That's how you find area, volume, right? Length times width times height. Length times width gives you area, height gives you volume. So it would make sense in that case to multiply meters times meters times meters, so that I would get a unit, meters cubed. But think about how big a box a meter cubed would be. It would be a meter tall, a meter wide, and a meter deep. That's a big box. So when you're going to the grocery store, how many meters cubed of soda do you want? You couldn't carry it out the door. Okay? You could not carry a meter cubed of soda out the door. It was way too much. So they don't use meters cubed. That's why they had to come up with a new unit for volume, and they called that new unit the liter, right? Okay? So this is a liter. Okay? What I have here is a liter. Okay? It's a little block. Okay? And each side is a decimeter long. It's got a decimeter along the top, decimeter along this side, decimeter down here. So this is a liter. Little block. Okay? So to find the volume of that, I would multiply 1 decimeter times 1 decimeter times 1 decimeter and get 1 decimeter cubed. That's pretty easy math. But a decimeter is 10 centimeters. So I could also say, a decimeter is 10 centimeters, that along this side, if it's 1 decimeter, that would be 10 centimeters. I'd have 10 individual little blocks along the side of this. So I could do that math. 10 times 10 times 10 is 1,000. And centimeters times centimeters times centimeters is centimeters cubed. So 1 liter is 1,000 cubic centimeters. It's hard to tell with this block, but if you were to count all the little blocks on here, that the corner's a block, then there'd be a block here, there'd be 10 blocks along this side, and there'd be 10 blocks along this face. So this whole face would be 100 blocks, and I would have 10 of those along the depth of it. So that would get me my 1,000 little blocks. That's how I got 1,000 centimeters cubed. Now, I'm going to do a little bit of algebra, but it's pretty straightforward. I'm going to divide both sides by 1,000. Well, I say, well, that's kind of silly. Well, I'm just wanting to, okay, I told you 1 liter is the size of 1,000 cubic centimeters. How big is 1 centimeter cubed? Well, it turns out that it's 1/1000th of a liter. But we have a way of saying 1/1000th. We got a prefix that means 1/1000th. So a milliliter is the same size as a centimeter cubed. In fact, sometimes they will write cc for cubic centimeter. So if you buy a motorcycle engine, the engine is measured in cc's. 1,300 cc's. When you buy a car engine, it's measured in liters. 5.0 liters. What it looks like they're completely different things, except I can turn cubic centimeters into liters because there are 1,000 cubic centimeters a liter, so this is really 1.3 liters. So 1 milliliter is 1 centimeter cubed. And we use that, chemists use that every time we want to go from talking about things that you measure with a measuring cup, liters and milliliters, and I want to talk about things you measure with a ruler, centimeters cubed. It's one place we can change in between things with a ruler to things with a graduated cylinder. For mass, pick the gram, and this is what they picked to be the gram. A gram would be how much one little block, one of these little corner blocks weighs if it were filled with water at 4 degrees Celsius. We'll talk about why 4 degrees Celsius later, but what it turns out to be, that's when water's its most dense. That water gets more dense as it gets colder, and you know that if you've ever jumped into a lake. The deeper you go, the colder the water gets. That's because that colder water is denser. So if 1 gram of water equals 1 centimeter cubed, then 1,000 grams of water has to equal 1,000 centimeters cubed. See why that has to be true? But we have another name for 1,000 grams. And we just learned what 1,000 cubic centimeters look like. So a kilogram is the weight of a liter of water. So if you want to get a sense of how big a kilogram is in your hand, a 1 liter water bottle is a kilogram. And so the reason why I knew you would not pick up a meter cubed of water or soda is because in a meter cubed, there are 1,000 liters. So that to carry the meter cubed of sodas out, you would have to carry 1,000 kilograms, which is about which is over a ton, which I don't think a shopping cart could even handle. I know I wouldn't want to put a ton of groceries in my shopping cart. That'd be a real drag because it wouldn't roll anymore. So it works out that a kilogram is about 2.2 pounds. I don't know why I put 2.5. It should be 2 pounds. People in the rest of the world weigh themselves in kilograms. When you buy meat in Europe, you tell them how many kilos of meat you want. You don't buy by the pound, you buy by the kilo. Okay, as we said, a gram was the weight of a raisin. It's also about the weight of a paperclip. It's a little one. We will be using milligrams. Milligrams is about the weight of 10 individual grains of salt. So if you could take the salt shaker and pick out just 10 individual grains, that's about a milligram. So a milligram is a tiny weight. So those are the parts of the metric system. We've got base units and we got prefixes. And the beauty is the prefixes get used over and over again. The beauty is those prefixes are about doing math with tens, which we can do in our head. Okay? So just to make sure everybody's on about the same page, I want to do a little check here. So right now, if you could look at the module, and in that module, there's one that says metric estimates. Should be third from the bottom. Okay, it says metric estimates right here. Okay, I'm going to put you in a breakout room, and I want you to answer those questions. I'll give you about 3 or 4 minutes. Okay, it should be pretty quick.